Good evening, everybody. Now we're going to use logs to solve these exponentials. Now you'll remember earlier we used common bases. So looking at this problem here on page 53, using common bases, I would bring the 4, and that would become 2 squared. I would take the 8, I would use menu 2, 3, that would become 2 cubed. I would apply the power to a power rule and multiply. I would dump the bases and say 2x equals 3. I would divide, and x would be 1.5. So now, using that work that we had gone through, looking at the base, start with the base of 4. I will write log base 4, loop over to the 8, and that will equal x. That's how I will convert it back and forth. Okay? So now, that is something I can type in the calculator. So, log base 4 of 8 is 1.5. Exactly what we wanted. Alright, so let's practice a little. This one, the exponent is the variable, so we need to change it to logs. So, log base 5, loop over, get the 18, equals x. Throw it in the calculator. Log base 5 of 18. And we get that lovely decimal, round to the nearest hundredth. So I'll write it all out, 1.7958, blah, blah, blah. Hundredths is right there, so I'm going to say 1.5 rounds that one up. So it would go up to 10, so that makes it 8.0. Let's do one more. Here we go. Log, the base is 4. Loop over to the number equals x. And I will get x equals 3.32. So now we just up the ante a little bit each time. Still exponential here, still variable in the sky. Turn it into logs. Log base of 6, loop over, make the circle of 50 equals x plus 3. So just one extra step here. So start log base 6 of 50 is 2.18333, x plus 3. Subtract the 3 over, and you end up with negative 0.8166. So again, nearest hundredth, so negative 0.8182. Okay, let's do that again. Same process here. Base is 1.03 of 2 equals x over 2 minus 5. So first step, log, find out what that is, 23.4497. And even though I'm only writing some of it, I'm keeping all of it in the calculator. So my next step, I have that whole decimal there. I'm going to add 5 to it, so just add to the answer. So that's 28.44977. And to get rid of the divide by 2, I will multiply everything by 2. And I'm done. 56.899. So 56.90. Okay, up it again. At this point, it's not just the exponential equals some number. There's more stuff going on. So first, get it to a format that it is. Okay, it's still not what we want. Divide by 4. Now I have a base to an exponent that is a variable equals a number. Now I'm back in the format I was. Log base 2. This is the base. Loop over to the 5 equals x. So log base 2 of 5, x equals 2.32. And they didn't give me a round, so I'm going near hundreds because that's what the page did. So looking at B, you're going to do that one. C, step 1, subtract the 2.5. 7e to the 2x equals 17.5. Divide by the 7. That's just going to easiestly written as an ugly fraction. So now, base, exponent is a variable, ugly number. Because the base is e, we could write log e, or you can just write natural log of 17.5 over 7 equals 2x. Remember to use the natural log button, which is above the e. Make a fraction here, 17.5 over 7, and then lastly divide by 2. So that will go 0.46. Okay, when I have these log situations, there's multiple ways they can happen. Well, there's 3. So what we just did was form 1. There was no logs, so I had to convert the exponential to a log, and I solved. Problem next, log on both sides. Now, simplify it so it becomes just one log on each side, and then when we have the same base, that they both have a log, you can drop those, okay? And then continue to solve. And number 3, log on one side, you're going to use the log properties that we did last time, push those together, then you'll turn it into exponential. So let's do some of this. So we've already done choice 1. We're going to do choice 2. Okay, here we are. Log base 3, log base 3. They are the same base, so we can push them together. They're addition of 2 separate logs, so we will say multiplication. I'll go ahead and simplify that. Distribute 3x plus 15 equals 4. Now, if I just typed this in, it wouldn't work because I have the variable on this side, so I'm going to take the log and turn it into exponential. Base of 3, loop over to 4 equals 3x plus 15. Now, I can type in 3 to the 4th, get 81. Subtract the 15. Get 66. Divide, and I will have 22. Okay. Now, let's do another one right here. Now I have natural logs, but that's okay. They work the same way. So natural log of x times 2x minus 1. 2x squared minus x. I've distributed my x through. Now, it doesn't say it there, but we remember base of a natural log is e, loop over to the 0, is 2x squared minus x. E to the 0 is 1. Subtract the 1 over. Normally, we don't bring things over, but we now can see I have a trinomial there. Yep, they made that just magically appear. And I have x and x, 2x and x. This outside term makes 2x, so I want to make that negative, and the inside is plus. So I solve these. 2x plus 1 equals 0, x equals negative 1/2, and x equals 1. So this one is negative, so we're going to cross it out. We reject our negatives. Let's take a look at one more where the logs are on both sides. So now I have this subtraction here. So I have subtraction means division. And I have logs on both sides. Both logs are base 10. They're there. We've simplified it down to 1 log on each side. I can cross those out and write just what's left over. I'm going to put the 3 over 1 so I can cross multiply. I distribute it, and now let's see, subtract the x and add the 9. So 2x equals 20, divide by 2, x is 10. Okay, and you can see, similar problem here. Now it's natural logs. And you'll see what that does, that even though it's a natural log, the properties are going to be the same. This will become division. Then we will have to cross multiply. It'll be delightful. Let's do one more, little quick one here. Let's do number 2. So the plus means I'm going to multiply. So it'll be 9 times x. The 2 in front is the exponent. So 9 squared is 81. Now log base 3 on both sides, cross them. 81x equals 27. Divide by the 81, x is 1/3. We will of course practice this more in class. Have a wonderful night.